Welcome. So this is the solution to problem 14 in chapter 3. So I've got these model A and B's. I can manufacture them at my Newark plant, or I can purchase them. I've basically got my skeleton structure set up. The idea here is that I want to minimize my costs. So what are those costs? According to this problem, that's 10, 6, 14, 9. Put in some placeholders for the variables, right? So my choice variables are the number of products A I'm going to manufacture, the number of product B I'm going to manufacture, the number of product A I'm going to purchase, B that I'm going to purchase. All right, my objective function. Well, some product. Okay, easy peasy. All right, parameters for my constraints. So demand for model A. Well, that's just 1, 0, 1, 0. Demand for B, 0, 1, 0, 1. And then I have my injection molding time. So that's 4 if I want to produce A and 3 for B. And then my assembly time, well, that's 6 if I want to manufacture A, 8 for B. And let me go over here. So these two constraints are equal to's, and these two are less than or equal to. Okay, so let me shorten that up. Okay, almost there. Demand for A, that was 100, 150. Injection molding time, I had 600 minutes, I think. And then assembly time, 1080. Okay. Shorten that up, see if that fits. Not quite. Well, there we go. Okay. So here's, 0, 0. You don't have to put in the zeros. In fact, you know what? I'll just leave them blank. You don't have to put anything in there. Okay, so now I need my constraints based on how many units I either purchase or manufacture. So another some product function, choice variables, parameters of the constraints, hit OK, anchor the choice variables, and copy down. All right. I should say one thing as we go through these homework videos. You might get a little tired of the repetition, and I don't blame you for that. But I do want to say one thing: the repetition, in my opinion, the repetition for these linear programming problems is important, right? Because you just do the same thing. Don't get out of sequence. If you can develop a plan in your head that works for you, stick with that, right? The way I set them up, this just works for me. And it helps me to understand the problems better. So I want to encourage you to find that repetition, that way of setting up the problem that just makes sense for the way you think. And then once you found it, stick with it, regardless of what I do, regardless of what your classmates do. Just stick with it. Okay, enough with that. So we are now ready to solve this problem. So I'll do the solver. My objective function, I want to minimize this by changing these 4 cells. And I want to set these two constraints equal to these two numbers. And then I want to set these two constraints less than or equal to these two numbers. I got my non-negativity constraints, simplex LP, solve, answer sensitivity and limits report. Hit OK, and there you go. Okay, so what is the optimal solution? Well, right here. I want to manufacture 100 units of product A, 60 of B, and then I want to purchase 90 units of product B. By doing so, my cost will only be $2,170. Okay, which constraints are binding? So I got 3 constraints. These 2 constraints are binding, and then so is the, what was that, assembly time. Again, binding, binding, not binding. Okay. What are the dual values? Interpret each. Okay, so I have to go to my sensitivity report. Okay, again, the dual values in Excel are called shadow prices. So demand A, if the demand for product A was increased by 1 unit, my cost would increase $12.25. For B, if demand for product B were increased by 1, my cost would go up $9. Now the injection time, I'm sorry, I said that wrong. The injection, what was that? Yeah, injection time. Because this is a non-binding constraint, the shadow or dual value is 0, right? And then for my assembly time, if I increased my assembly time by, what was that, 1 minute or hour? Minutes, yeah, minutes. If I increase the assembly time by 1 minute, my cost would actually decrease, right? What's going on here is you'd start to move, my assumption is you would start to move away from purchasing B and manufacturing instead because you have more time. All right, so that is the interpretation. If you could change the right-hand side of one constraint by 1 unit, which one would you choose and why? I would choose assembly time because by increasing that 1 unit, my minimum cost would decline by 38 cents. All right, so there you go. There is problem 16 in chapter 3.